Welcome you all to the lecture series of Detailed Electronics KE 039/049. Myself Dr. Kishanu Kundu, Assistant Professor, Department of Electronics and Communication Engineering, GL Bajaj Institute of Technology and Management, Greater Noida. So, we are discussing about synchronous sequential circuit. This is the part 3 lecture. Already in first part and second part in the previous lectures, lecture number 20 and 21, we have discussed elaborately about synchronous sequential circuit. We have discussed about the designing part, and today in this lecture again we will be discussing about the design part in detail. So, let us proceed. So, today's lecture's table of content is that we will be now deriving the state table and state diagram for the sequential circuit Mealy and Moore. Okay. In the previous lectures we have taken the state table, state diagram, and from the state diagram itself we have made the sequential circuit. Now, we are going to do the vice versa. We are having the circuit, and from the circuit we have to derive the state table and state diagram. Okay. This both type of questions can be asked in the exam. First of all, they can give you the state diagram and they can ask you to design the circuit, and also they can give you circuit and they can ask you to design the state diagram and state table. So, in previous lecture, lecture number 21, we have designed the sequential circuit from the state diagram given, but in this lecture number 22, we are going to design the state diagram as the sequential circuit is now given. Okay. So, let us proceed. Already we are having the concept that there are two type of circuits, Mealy and Moore. Okay. In Mealy the output is depending on present state as well as external inputs, but in Moore circuit the output only depends on present state. Okay. So, that we have to check. So, in the steps are there, first of all we have to check the given sequential circuit in the question is which type, Mealy or Moore. This is very important. That also we have seen in the state diagram. In the previous lecture also we have seen that if we from the state diagram itself it is clear that which type of circuit you are going to build, Mealy or Moore, and here also from the circuit itself you can check that the output is depending on the state as well as input, means it is Mealy, right. So, first of all check that if the circuit is given, what is the given in the question is Mealy type or Moore type. Next, we have to write the excitation equation according to the given circuit. From the circuit itself we will write the excitation equation, then write the characteristic equation according to the used flip flop circuit design. So, whatever the flip flop is used in the circuit, you have to write the characteristic equation for them, and as per characteristic equation design the state table, and finally from the state table you have to find out the state diagram. Okay. So, first of all we have to check that which type of circuit it is there, Mealy or Moore. Then from the circuit itself we will write the excitation equations. From the excitation equations we will have to write the characteristic equation for the used flip flops, what the type of flip flops is used in the circuit itself. Then as per characteristic equation we design the state table, and from the state table finally you have to build the state diagram. So, let us take an example and we will proceed. See, here it is given, derive the state table and state diagram for the given sequential circuit. Here one sequential circuit is given, right. They are asking you to derive the state table and state diagram. So, first step is to find out it is Mealy and Moore. How we will find out? We will just look at the output. If the output is depend on the present state and the input, then it is Mealy. If the output is only dependent on the present state, then it is Moore. So, let us check it is Mealy or Moore. See, check the y, this is the output y. What is the value of y? Y is nothing but, here three things are coming. One is B, this is B, this is A bar, and this is x. Very clearly you can see that y is equal to A bar B x, means it is depending on present state as well as input, means it is a Mealy machine. From the very beginning you can check it out, it is milli or more. So, it is milli circuit, it is milli circuit, the circuit is milli circuit. Our first work is done. First of all we have to check the milli or more. So, it is milli circuit. Now, we have to write the equations. The equations, see, this is flip flop A, this is flip flop B. Here we have used JK flip flop, here we have used JK flip flop. So, the equation is output equation we have got, this is y is equal to A bar B x from the circuit given, okay, from the circuit given we are doing. So, now what is the value of J? What is the value of J? Look at the diagram. J is, this is nothing but B and this is X and this is OR gate, this is OR gate, this is OR gate, this is AND gate, right. So, X and OR B. So, the value of J is equal to B plus X, clear. What is the value of K A? K is directly, it is given A. So, K is nothing but A. From the diagram is this one, clear, K is equal to A. Now, what is JB? JB is nothing but, here it is going X and this is A bar and one we are having OR gate, okay. So, this is JB will be X plus A bar, X plus A bar, clear. What is KB? KB is only B. So, KB is nothing but B, okay, and output Y already taken. So, our second step is also covered. We have written the equations from the circuit. First part of the step is over, means we have written the equations JB, KB, JA, KA and output. 5 equation what is given in the circuit we have written, okay. Now, our work is to write the excitation equation. So, here just I have already done this thing, the output depends on the present input. So, this is milli, already I have discussed in the previous slide. See, it is a milli circuit and here we are having the excitation equation, again we are writing for flip flop A we are having J is equal to X plus B and K is equal to A, and for JB is equal to X plus A bar and KB is equal to B. Already this is written here, I am just rewriting that in the next slide. And what is the value of Y? Y is nothing but A bar B x. Done. The excitation equations are completed from the circuit itself, okay. Now, next step. Now, we have to write the characteristic equation, right. It is given in the step, see, we have to write the characteristic equation according to the used flip flops. So, here we have used JK flip flop. So, we will follow the characteristic equation of JK flip flop, right. Again I am telling, if you having any doubt about the excitation table, characteristic table, just refer the video lectures of flip flops, you will be getting bigger idea about the both the type of tables, okay. Your concept will be clear from the flip flop slides. So, see, this is the characteristic equation Qn plus 1 is equal to Qn bar j plus Qn k bar. You can write like this also, Qn bar j plus Qn k bar. This is the characteristic equation for JK flip flop. Now, we have to rewrite this equation using that, okay. We have to write down this. So, what will be the next state of flip flop A plus n plus 1 for flip flop A, this is flip flop A, right. So, it will be Q A bar J A plus Q A K A bar q a bar j a plus q a k bar, and we are writing q a is equal to a and q a bar is equal to a bar. Okay. Right. So, what will be the value of j? The value of j is x plus b, value is j x plus b. So, we will write as j is equal to x plus b and q a bar is equal to a bar. So, we will be writing like that, a bar x plus b. Is it clear? And what is q a? Q a is a, and what is k a bar? K is equal to a. So, a bar is a bar. Now, you know that a into a bar will be 0. So, we will be having only a bar x plus b, a bar x plus b. So, we will be having the equation a bar x plus a bar x plus a bar b. This is the next state of flip flop A. Clear? Got it? Now, for flip flop B, n plus 1 will be q b bar j b plus q b k b bar. Okay? Using this equation only, using this equation only. This is the final main characteristic equation. So, we are taking q b is equal to b, q b is equal to b and q b bar is equal to b bar. Okay. So, now let us write. So, q b bar means b bar, and what is j b? J b already you have got x plus a bar, x plus a bar. So, it is write down b bar into x plus a bar. Okay. And what is q b? Q b means b, and what is k b? K b is nothing but b. So, it will be as b bar. Again b into b bar will be 0. So, we will be having only this value b bar x plus a bar. Just write it down, b bar x plus a bar b bar. Okay. So, these two characteristic equation we have done for the given circuit. Okay. So, now from this equation, these two equation, this is the main equation for flip flop A and flip flop B. This is the equation. Again I am going to write in clear way. This is for flip flop A, q n plus 1 will be a bar x plus a bar b, and for flip flop B, q n plus 1 is equal to b bar x plus a bar b bar, a bar b bar. Clear all of you? X b bar plus a bar b bar, and this is a bar x plus a bar b. So, these two equations, these are the main final characteristic equation of the two flip flop. So, using these two equation we will be now getting the state table. So, let us proceed. So, this is the state table. Again I am writing the equation once more. For flip flop A, q n plus 1 is equal to a bar x plus a bar b, and for flip flop B we will be having a bar b bar plus x b bar. So, now we will be having the values of x here, x a or b and like that we have to make this table. Just put the values of x, a and b in these two equations. Put the values, put values of x, a and b into this equation. Okay. So, we will be having the values. So, when will be, and the output is y is equal to a bar b x, a bar b x. Okay. So, finally, we will be getting for 0 0, we will be getting 0 1 for this 1 1, 1 0, then 1 0, with 0 0, 0 1, 0 0 and 0 0. Okay. Is it clear to you? Then output values will be for this equation, for x equal to 0 will be having 4 times 0 and will be having 0 1 0 0. Okay. Clear? So, formulation of state table is also done, right. Now, finally, we have to make the state diagram. So, the just following the state table we will be making the state diagram. So, let us start the state diagram. So, the formula 0 0 0 1 1 0 and 1 1. Okay. Just follow this, state table and you can write the state diagram. So, I am writing the state diagram. So, one is 0 oblique 0, it is going to like this, for 1 0 it is like this. Now, for 0 1 we are going to 1 0, means we are getting 0 0, and for 1 1 we are going again to this. Okay. Now, for 0 0, 0 oblique 0, and if I go into this, then get 0 0. Anything remaining, you can check it out from 1 0. If we giving 0, so 0 0 is going 0 oblique 0. Okay. If we giving 1, it is going to 0 1. Okay. And output is 0 0 1 0 1 going to 0 1 1 0 say 0 1 1 0, it is going to 1 0 to 0 1, and the output is 1 oblique 0. This will be 1 oblique 0. Okay. And the final one 1 1 is, in the both case it is going to 0 0 for 1 0 1. So, this will be for both the case, for 0 0 and for for both the case it will be also as 0, the output will be 0. So, it will be 0 oblique 0. So, this is the formation of final state diagram. From the equation we have written the state diagram. Okay. Clear? So, now take another example. Here also one circuit is given and they are telling you to derive the state table and state diagram for the given sequential circuit. So, for the given sequential circuit, now you just check it that it is what type of circuit, Millet or Moore. This is on to you, what type of circuit is this, Millet circuit or Moore circuit. So, here output y, first of all check what is y. Y is nothing but A, this is A and B, XOR of A and B, XOR of A and B, means it means that we do not, the output, it does not depend on external input, it is only on present state A and B, right. So, for that it is very clear that this is nothing but Moore circuit. First your work is to find out which circuit is given and for whom, which type of circuit we are going to make the state diagram or state table. So, it is Moore circuit, right. So, you can the thing is that output depends on present state of the flip flop. So, it is nothing but the Moore circuit. Okay. Next, what type of flip flop is given? JK flip flop. Here JK flip flop is given, JK flip flop. So, what will be the value of JA? Just check what will be J. J is means this is nothing but B. B is connected to J. Yes, I think B is connected to J. So, J is equal to B. And what is K? K means this is B and this is X bar, B and X bar, since B X bar, K is equal to B X bar, right. What is JB? What is JB? JB is equal to X bar, JB is equal to X bar, clearly it is written this one. And what is KB? KB is nothing but A bar X का XOR gate, A bar X का XOR gate, right. This is no, this is A, this is X and this is XOR, this is XOR, this is also XOR. See, so A XOR X, KB is equal to A XOR X. So, all 5 equation we have got. This is for output, these are J, K, JB and KB. Okay, clear? All excitation table excitation equations are made. So, again we am writing here. So, JA for flip flop A, JA is equal to B. Already I have written in the previous slides, J is equal to B and K is equal to BX bar. J K A is equal to Bx bar, and what is JB is equal to, JB is equal to X bar, JB is equal to X bar, already written JB is equal to X bar and KB is equal to A XOR X, KB is equal to A XOR X. Okay. And output Y is equal to nothing but A XOR B. Okay. Clearly all equation have been made, right. Now, we have to make the characteristic equation using the excitation equation. So, we already know that this is the characteristic equation for JK flip flop. So, will be for flip flop A, for flip flop A we are taking QA is equal to A, and for flip flop B we are having QB is equal to B. Already the same procedure whatever even we have taken from the last example. So, flip flop A will be A n plus 1 will be Q A bar J A plus Q A K A bar. So, what is the value of Q A bar? Means A bar, what is J A? J is nothing but B. So, you have to write B. And what is Q A? Q A means A, or what is K A? K A means B x bar, means B x bar का whole bar. क्योंकि K A bar it is even K A bar. So, it will be like that we can write down A bar B plus A. From using De Morgan's theorem we can rewrite this as B bar plus X using De Morgan's theorem, right, because we know na A dot B is equal to A bar plus B bar. Okay. So, like that using De Morgan's theorem we have taken this step. Okay. So, finally, we can write B A bar B plus A B bar plus A x. This is the equation for flip flop A, clear. And for flip flop B, we have Q n plus 1 is equal to Q B bar J B plus Q B K B bar. So, what is Q B? Q B means B, B bar, what is J B? J B means X bar, J B means X bar. So, So, it will be as x bar. Now, q b is b, already second na, q b is equal to b and q b is to a. Okay. So, q b is equal to b and k b bar means what is k b? A XOR x. So, it will be a XOR x. Okay. Got it? So, you can write like that b bar x bar. Now, XOR formula a x plus a bar x bar b. Okay. Got it? And finally, we are having y is equal to a XOR b, then okay, here it is on bar is also there, that is why it is XNOR gate. Now, XOR has become XNOR, right, remember this, and this is a bar b plus a b bar, a bar b plus a b bar, this is y, this is value of output and this is the value of qn plus 1 for flip flop b, and this is for flip flop a for flip flop b, and this is the output. Got it? So, from this we will make the state table. So, state table it is easy, just put the values in the equations and we will get the values. So, we will be getting this 0 1 for x equal to 0 we will be having 0 1 for 0 0, then 1 1 1 0, then 1 1 1 0 and 0 0 0 1 0 1 1. Okay, the output are 0 1 1 0. How will get this output? We are having the out formula na, y is equal to a bar b plus a b bar. So, just put the values of a and b here, you will get this value, right. Similarly, you will get the next state for this is for flip flop a, this is flip flop b. Okay. Now, this is for flip flop a, this is for n plus 1 and this is bn plus 1. Okay. Finally, we have got the state table, and from state table finally, we will do the state diagram. Already in the beginning itself we are having that this is a Moore. So, Moore the output will be in the state only. So, just convert this state table into state diagram. So, finally, it will be like that 0 0 oblique 0, because see the output is 0, then for 0 1 it is 1, see for 0 1 it is 1, for 1 0 it is 1, for 1 0 it is 1, and for 1 1 the output is 0 0, 1 1 the output is 0. Okay. Now, the transition when we are having next stage is equal to 0, 0 0 will 0 1 and 0 0, 0 1 and 0 0. So, for 0 and it will go back to for 1, clear. Okay. Next, for 0 1 if the input is 0 1 1 and 1 0, 1 1 and 1 0, 1 1 and 1 0. So, for 0 it is going to 1 1 and for 1 it is going to 1 0. Okay. Next, for 1 0 1 1 and 1 0, 1 1 and 1 1 for 0, and for x input 1 it is going to 1 0, means it is coming back to itself only 1, and the last one for 1 1 if it is going to 0 0 and 1 1, okay, 0 0 and 1 1. So, it is going to 0 0 for 0 and going back to itself only as 1 1. So, I think the state diagram is complete. Okay. So, you can check it that two type of circuits are given. First one it was given Melee circuit from the output, just check the output. If it is input term is there, means it is a Melee circuit, and like that you can proceed. Okay. And here also in this diagram, just check the output. Here see no input is there, output is not depending on input, it is only depending on the present state. So, we can say that it is a Moore circuit, and according to have make the state diagram. Okay. So, these are very important for your exam point of view.